In this video, we're going to look at these problems on page 4 of the 6.3 slides. In our first problem, a coin is tossed 3 times and the sequence of heads and tails is recorded. We're asked to use the generalized multiplication principle to determine the number of possible outcomes of this activity and then exhibit all the sequences by means of a tree diagram. So, back over to our paper. By the generalized multiplication principle, there are 2 options when we flip a coin. So that's 2 times 2 times 2 for 3 coins, which is 2 cubed, or 8 possible sequences. To illustrate those sequences, we use a tree diagram. And I'm doing this wrong. We only need 2 branches. We can either have heads or tails. And we have heads or tails each time we do this. So we can have 3 heads, 2 heads and then a tail, a head, a tail, and then another head, a head and then 2 tails, a tail and 2 heads, a tail, a head, and another tail, 2 tails and a head, or 3 tails. That's the first problem. Our next problem a combination lock is unlocked by dialing a sequence of numbers first to the left, then to the right, and then to the left again. If there are 10 numbers on the dial, determine the number of possible combinations. And then it further asks us how many combinations are possible if no digit is repeated. So for this one, first, we're asked how many combinations are there if any of the 10 digits is viable at any point. So that's 10 times 10 times 10, or 10 cubed, which is 1,000 combinations. If the digits can be repeated. If digits can't be repeated, it's a little different. We have 10 options for the first number, but we have to take one of those away, the one that we use, when we go to the second number. So that's 9. And then we have to take that one away as well when we go to the third number. So there are only 8. 10 times 9 times 8 is 720 different combinations. That is it for this video. If you have any questions, please get in touch.